Question 41 from the homework is a pretty good question, and it combines a couple different calculations that we're going to have to do. So we've got a 2.23 gram sample of a non-electrolyte. So this is very important. Dissolved in 50.4 grams of water, and we observe the solution freezes at minus 1.23 degrees Celsius. What is the molar mass of the solute? So the first thing, our calculation that we're going to have to do, our change in our freezing point equals negative I, or negative Van Hoff factor, times Kf times our molality. So right now, we know our change in freezing point. We also know our Van Hoff factor, and this is a constant. So we know, the first thing is we need to find what is the molality of this solution. So I said it was important that we know it's a non-electrolyte, because a non-electrolyte goes into solution as a molecule. It's going to have a Van Hoff factor of 1. Our freezing point constant, it's not given, but we can easily look that up. The freezing point constant for water, 1.86 degrees Celsius per mol. So our change in freezing point, well, we normally freeze at 0 degrees Celsius. I observe it to freeze at minus 1.23 degrees Celsius times a negative 1 times 1.86 degrees Celsius per mol. And I don't know the molality of this solution. So that's my first unknown, the molality of this solution. So I'll divide across by a negative 1.86 degrees Celsius per mol, divide across by a negative 1.86 degrees Celsius per mol. And I find the molality of this solution to be 0.66. And so now we need to think, what does molality mean, right? We know molality is moles per kilogram of solvent. And we know that we've got 50.4 grams of water as our solvent. So I know the molality, and I actually know the kilograms of solvent. So I've got a 0.66 molal solution. I want to find X moles, and I know that solution is 0.0504 kilograms. So we multiply that across, and we get approximately 0.0333 moles of our unknown electrolyte in solution. And again, we have to ask ourselves, okay, where can I go with this? Well, I know moles equals grams over molecular weight. So let's see. I know I have 2.23 grams of this unknown in solution. So again, I've got 0.0333 moles equals 2.23 grams. I don't know the molecular weight. That's my unknown. So I'll multiply, then divide across, and I should get a molecular weight of this unknown of approximately 66.9 grams per mole. So I don't know what the unknown is. I can't say it's this thing, but I do know it's a non-electrolyte, so it's a molecular compound. And based on this information, based on the change in the freezing point of water, the molar mass of this compound is approximately 66.9 grams per mole. So 3 different calculations we had to do there. First, we had to find the molality, which we could do given the change in freezing point and the freezing point constant for water, and that we had a non-electrolyte in solution, so a Van Hoff factor of 1. Once we figured out the molality of that solution, we know how to calculate molality, so we could find, using the mass of that solution, we could find out how many moles we actually have in solution of that unknown, and then given the mass of that unknown, we could use that to find the molar mass of that compound.